Good afternoon, friends. In previous lecture, I have discussed the methods of isolation and also the methods of preservation of microorganism. In today's lecture, we will see the physical parameters which is required for growth of bacteria or physical parameters for bacteria and different types of culture media. Before that, we will see what is growth. Yes, it is orderly increase in the quantity of all the cellular constituent, that is growth. The growth of microorganism is influenced by what? Whereas physical and chemical factor of their environment. There are two main factors, that is physical factor and chemical factors. Then in physical factor there are temperature, pH, then osmotic pressure, hydrostatic pressure and radiation. These are the physical factors. And then chemical factors, for example oxygen, then carbon, nitrogen, phosphorus or sulfur. These are the few physical and chemical factors. Physical factors which is affect on growth of microorganism, that is temperature, pH, osmotic pressure, then hydrostatic pressure and radiation. We will see one by one. First, temperature. Temperature is most common factor or most important factor that determine the rate of growth, then multiplication, survival and death of all living microorganisms or death of all living organisms. The high temperature damages what? Microbes by denaturing the enzymes, then transport carrier and other protein. Yes, high temperature it damage to what? Damage microbes by denaturing the enzymes and transport carrier and other proteins. Then microbial membranes are disrupted by the temperature. Also the high temperature causes disruption of microbial membrane. Then at very low temperature membrane also solidify and enzyme also do not function properly. If there is very low temperature, then it causes the membrane get solidify and enzymes also do not functioning properly. That is, at very low temperature there is improper functioning of enzymes. And second thing, that is the membrane get solidify. Next, that is types of temperature. First, minimum growth temperature. Second, optimum growth temperature. And third, maximum growth temperature. We will see one by one. First, minimum growth temperature. It is the lowest temperature at which organism grow is the minimum growth temperature. Then second, optimum growth temperature, the temperature at which the most rapid rate of multiplication can occur. And maximum growth temperature, the highest temperature at which growth occurs. A temperature only slightly above this point frequently kill the microorganism by inactivating the critical enzymes. Then classification of bacteria according to the temperature, according to the growth temperature. First, psychrophiles, then mesophiles, or we can say psychrophiles, then mesophiles, thermophiles and hyperthermophiles. This is the graph which shows growth rate versus temperature. It means the psychrophiles, then mesophiles, thermophiles, then hyperthermophiles. Next, first, that is psychrophiles. It is also called as cryophiles or cryophiles. The term psychrophiles was first used by as Chimdit Nelson. The extremophilic organism that are capable of growth and reproduction in cold temperature. And the temperature range for the psychrophiles, it is -20 to +10 degrees Celsius. For example, Oscillatoria, then Chlamydomonas, Nivalis and Methagenium. These are the few examples of psychrophile organism. Then mesophiles, the growth based in moderate temperature, that is the growths or the bacteria can grow at best in moderate temperature and having temperature range, it is 20 degrees Celsius to 45 degrees Celsius. An example, E. coli and Streptococcus pneumoniae. Then psychotrops, it is cold tolerant bacteria having optimal and maximal growth temperature above 40 and 20 degrees Celsius respectively. Then psychotropic bacteria and fungi are the principal causes of spoilage of refrigerated food. Yes, what is important in this, that is it causes the spoilage of refrigerated food. Then next, for example, Pseudomonas Aeromonas, then Bacillus and Clostridium. These are the few examples of psychotrops. What are those examples? Pseudomonas, then Aeromonas, Bacillus and Clostridium. The next, thermophiles. It is derived from Greek word thermosia, meaning it means heat, and philia meaning love, that is it is heat loving microorganism. Yes, what I am saying, it is derived from Greek word thermosia, it means heat, and philia meaning it means the love, that is thermophiles, these are the, or it is heat loving microorganism, and these microorganisms are grow at temperature that is 50 degrees Celsius or higher temperature. Their growth minimum is usually around 45 degrees Celsius or often optima, that is between 50 to 80 degrees Celsius. For example, thermus, then aquaticus, then geogema and barusi. Then hyperthermophiles thrives extremely at hot environment. For example, temperature range having 80 to 113 degrees Celsius. It is first discovered by Thomas D. Brock in 1965 in hot spring in Yellowstone National Park, Wyoming. The cell membrane contains high level of saturated fatty acid to retain its shape at high temperature. Yes, the cell membrane containing what? High level of saturated fatty acid. To retain the shape of this, it requires high temperature. For example, sulfolobus, then methanococcus. These are the few examples of hyperthermophiles. Then we will see pH. Here, what is importance of pH or what it affect? The pH refers to it means the pH, it is negative logarithm of hydrogen ion concentration. All of you know the definition of pH. Yes, what is pH? It is the negative logarithm of hydrogen ion concentration. Then the growth of microorganism is strongly affected by the pH of the medium. It means it is the major factor that affect on the growth of microorganism. Drastic change in cytoplasmic pH, it disturbs the plasma membrane or inhibit the activity of enzymes and also membrane transport protein. Yes, what I am saying, the drastic variation in cytoplasmic pH, it disturbs the plasma membrane or inhibit the activity of enzymes and also the membrane transport protein. Next, the classification of bacteria according to the pH. First, extreme acidophiles, then acidophiles, then neutrophiles, alkalophiles and extreme alkalophiles. Yes, classification of bacteria according to the pH. First, extreme acidophiles, then neutrophiles, alkalophiles and extreme alkalophiles. First, acidophiles, it means these are the bacteria which grows between the pH range 0 to 5.5. For example, Ferroplasma, Thiobacillus, Thiozidon, then Acidocalarius. Then alkalophiles, these are the bacteria which grows in the pH range of 7.5 to 14. For example, Thermococcus alkalifilus. Then neutrophils, the bacteria which grows the pH range having 5.5 to 8.0. For example, lactobacillus, then acidophilus and E. coli. And next, that is Pseudomonas aeruginosa. Then the bacteria prefer the media of pH nearly neutrality and usually cannot tolerate the pH value much below, that is 4 to 5. Then we will see the osmotic pressure. Osmotic pressure is a maximum pressure which needs to apply to a solution to prevent inward flow of water across the SPM. Then types of solution: hypotonic solution, isotonic solution and hypertonic solution. The water activity, it is calculated by the vapor pressure of solution divided by the vapor pressure of pure water. Then the classification of bacteria according to the osmotic pressure. That first, osmotolerant, and second, halophils. So what is osmotolerant? These are the microorganisms or those microorganisms which grows at relatively high salt concentration. Osmotolerant, it means those are the microorganisms which can grow relatively at high salt concentration. For example, Aeromonas species, then Staphylococcus species, then halophils. Then these are those microorganisms which grows in presence of salt. Those microorganisms which grows in presence of salt at concentration 0.2 to 0.6. For example, Halobacterium halobium. Then we will see the basic nutritional requirement. In that, first, nutritional requirement, the bacteria require what? The adequate nutrition, optimum pH, temperature and oxygen for their growth, that is for growth of microorganism as well as the multiplication of microorganism. Yes, what it required? First, adequate nutrition, optimum pH, temperature and oxygen for growth of microorganism as well as the multiplication of microorganism. The suitable official media, it requires the source of carbon, then nitrogen, hydrogen, oxygen, phosphorus and other elements, for example sodium, potassium, magnesium and iron. Yes, what it requires? The source of carbon, then nitrogen, hydrogen, oxygen, phosphorus and other elements, for example such as sodium, potassium, magnesium and iron in very small amount have been used for the cultivation of microorganism in laboratory. First, we will see one by one. The bacteria can be classified depending on the nutritional requirement. First, that is source of energy. The bacteria which derive their energy from sunlight are called as phototrophs. For example, Rhodospirillum rubrum. Bacteria which derive their energy from chemical reactions are called as chemotrophs. For example, Escherichia coli. There are two terminologies, that is phototrophs and chemotrophs. Phototrophs, it means, yes, there are two different terminologies or terms, that is phototrophs and second chemotrophs. So what is phototrophs? It means the bacteria which derive their energy from the sunlight, that is phototrophs, and the bacteria which derives their energy from chemical reaction, that is chemotrophs. Next, source of electron. All microbes require a source of electron for their metabolism. Yes, electron which is required for what? Their metabolism. The bacteria which use reduced inorganic compound as an electron donor is called as lithotrophs. For example, Pseudomonas pseudoflava. And second, organotrophs. Some bacteria which use organic compound as an electron donor is called as organotrophs. For example, E. coli. Yes, as per source of electron, there are two classification, lithotrophs and second, organotrophs. So what is lithotrophs? It means the bacteria which used reduced inorganic compound as an electron donor, it is called as lithotrophs. And second, organotrophs, some other species or some bacteria which use organic compound as an electron donor is called as organotrophs. For example, E. coli. Example of lithotrophs, Pseudomonas pseudoflava. An example of organotrophs, example E. coli. Next, that is source of carbon. The microorganism or microbes requires carbon for synthesizing the cell components. Some species use carbon dioxide or as a major source of carbon. This microorganism is called as autotrophs. For example, nitrifying bacteria. And other species, it requires organic compound as a source of carbon. This species is called as heterotrophs. As per carbon or as per the source of carbon, it is classified. That is first autotrophs and second heterotrophs. First, that is autotroph and second heterotrophs. So what is autotrophs? It means the some species use carbon dioxide as a major source of carbon. These microorganisms are called as autotrophs. For example, nitrifying bacteria. And second thing, heterotrophs, some bacteria which required or use organic compound as a source of carbon. These species are called as heterotrophs. For example, E. coli. Next, that is nitrogen. The bacteria can use nitrogen from the atmosphere or from the inorganic compound such as nitrate. Yes, example of inorganic compound, nitrate, nitrite, then ammonium salts, or organic compounds such as amino acids. Then nitrogen is the major component of protein and nucleic acid. Yes, nitrogen, it is the major component of protein and nucleic acid. Then sulfur is needed for what? Synthesis of amino acid. For example, cysteine and methionine. Then phosphorus, it is essential for component of nucleotide, nucleic acid and phospholipids. Yes, phosphorus, it is required for or it is essential for component of nucleotides, nucleic acid and phospholipids. Then mineral salts, growth factor or bacterial vitamins, and water, it is also essential for growth of bacteria. Mineral salts, growth factors or bacterial vitamins, it is also required for growth of bacteria. Yes, it requires water. Again, we will see the basic nutritional requirement: water, carbon source, nitrogen source, then inorganic salts, in that phosphate, sodium, magnesium, manganese, then sulfate, then potassium, iron and calcium. Then bacterial vitamins, in that thiamine, nicotinic acid, folic acid, riboflavin, pyridoxine and vitamin B12. Then gaseous requirement, in that oxygen and carbon dioxide. In oxygen, it is obligate aerobes, then facultative anaerobes, then microaerophilic and obligate anaerobes. In carbon dioxide, it is capnophilic. In temperature, as I said earlier, cyclophilic, mesophilic and thermophilic. This is the temperature range for cyclophilic, that is below 20 degrees Celsius. Then mesophilic, that is 25 to 40 degrees Celsius. Then thermophilic, it is 55 to 80 degrees Celsius. Then ion concentration, that is pH. Acidophilic bacteria, then alcoholophilic and neutrophilic. This is the pH range. Then culture media and its basic requirements. We will see in next lecture, that is types of culture media. So this is all about the physical requirements or the physical parameters for the growth of bacteria. We will stop here.